Hello everyone, my name is Skinny Jean Paul O. Amare. This is a vlog, and this is my very first vlog. And the topic of the vlog is faults, type of faults, and what is the use of faults in the civil engineering construction. I hope in this end of the video, many of you will watch the video learn something about the faults and the topic. So let's get started. First, what is faults? Faults and its importance in engineering constructions. Faults are fractures in earth crust along with slipping has occurred parallel to the surface of the fracture. Some are clean, sharp breaks, many however consisted of subparallel faults among which total displacement have been distributed. The term shear zone, Oxford zone are often used to be closely spaced subparallel structures along which there be distributive movement. Some faults are knife-like breaks. Other faults due to the frictional effects or rock masses sliding over one another break or crack the rock on either side of the rupture. Some faults pulverize the rock in the fault zone to clay-like powder, called gouge. By convention, the surface of the rupture along which relative movements have occurred are tame fault planes. The surface in most cases are warped or curved and irregular, and hence the term fault surface is parable into fault plane. Type of faults. First, normal dip faults are produced by vertical compression as the earth crust lengthens. The hanging wall slides down to relative to the footwall. Normal dip faults are provided by vertical compression as the earth's crust lengthens. The hanging wall slides down relative to the footwall. Dormer faults are common. They bound many of the mountain ranges of the world and many of the rift valleys found along the spreading margins. Second, reverse faults. Reverse dip slip faults results from horizontal compressional forces caused by shortening or contraction of the earth crust. The hanging wall moves up and over the footwall. Reverse dip slip faults result from horizontal compressional forces caused by the shortening or fraction of the earth crust. The hanging wall moves up over the footwall. Dip slip faults are inclined fractures where the blocks Second, reverse dip slip fault result from horizontal compressional forces caused by the shortening or the contraction of the earth crust. The hanging wall moves up and over the footwall. The reverse dip slip faults result from horizontal compressional forces caused by the shortening or the contraction of the earth crust. The hanging wall moves up over the footwall. Are inclined fractures where the blocks are mostly shifted vertically. If the rock moves up above the inclined fault moves down, the fault is termed normal, whereas if the rock above the fault moves up, the fault is termed reverse. Third, thrust faults. Thrust faults are reverse faults that dip less than 45 degrees. Thrust faults are very large with very low angle of the dip and a very large displacement, are called overthrust or detachment. This slip fault in which upper block or above the fault plane moves up and over the lower block. This type of faulting is common areas of compression, such as regions where one plate is being subducted under another, as in Japan. When the dip angle is shallow, a reverse is often described as a thrust fault. Fourth, strike slip faults, also called translucent wrench or lateral, are similarly caused by horizontal compression, but they release their energy by rock displacement in horizontal direction almost parallel to the compressional force. Fractures where the block have mostly moved horizontally if the block opposite an observer locking moves to the vault, moves to the right. The slip style is termed right lateral. If the block moves to the left, the motion is termed left lateral. Fifth, or the final, true fault. True fault is a system which two normal faults occur whose fault planes are inclined, providing a common down-through side between them. The downtown block between the two fault planes forms a long trench called a graben or a rift valley. Some gravens are very long, also deep, and may be filled with water to become water stream, and usually are defined as a rock mass laying between or more or less parallel faults or fault zones and depressed relative to the masses on each sides. The importance of faults in civil engineering construction. The main significance of fault in engineering lies as a plane of weakness affecting physical properties of rock. Fault may act as possible source of movement and may pose problem of the settlement, sliding, seepage, or systematicity to the civil engineering construction, depending on its nature on disposition and location. As a civil engineer, you should know what types of faults building you're gonna build in the place, because sometimes because some faults are very powerful earthquake and some faults are just very low, so you always gonna depends on the what materials you needed to the construction, to the building, to the place for the against the faults. Second, to provide earthquake-proof structure, it's necessary to have a knowledge of the location and the earthquake potential of faults. This is of particular importance in locating the sites for the dams, reservoirs, hydrostructures, underground power, nuclear power station, tunnels, public buildings, schools, and college building, etc. This is what I said minutes ago. Every dapat ilis ka og tani kung unsa imong fault, dapat na kanang necessary jud ang earthquake fault proof structures. You should not dapat bantayon po nimo unsa imong mga faults, bitaw ka nang dili you cannot just build something in that place if you don't know what are the faults in the location, because some faults are really powerful to the and can destroy many buildings. So this is very important as in civil engineering. If you build, even kung mag-build man jud ka sa fault, dapat necessary jud ang earth-proof structures or earth-proof materials para ma-against nimo faults, because the faults is the cause of your success or the failure of your construction building. Because if your construction building is destroyed because of the faults, your name will be destroyed, or say madaot ka. So it is necessary to know about the faults, the location of your building. So that's it, everyone. I hope many of you learn something to my blog, and see you later. Goodbye.